graphs. Alright? So, in this chapter, what we're going to learn? Only two things. We're going to learn about gradients and we're going to learn about equations of a straight line. Okay? Gradients and equations of a straight line. When you were in set 1, you guys learned a formula for gradient. I want you to write it down. But you must know when you are set 3 onwards, you will never use the formula again. I want you to write down so that you can have a linkage, okay? A linkage of what you have previously learned and what you're going to learn now. Anyone can remember what is the formula learned in set 1 of to find gradient? Yeah, the gradient, which is defined by the symbol m, was the rise over the run. Do you remember? It was the rise over the run. Now, specifically, what does it mean to rise over the run? Okay, I have to recap with you a little bit on what is gradient, because if you do not understand the concept of gradient, this chapter can be a little bit difficult. And I can tell you very honestly, many of you actually move on into JC and Poly without truly understanding what exactly is gradient. To you guys, gradient is some kind of weird mathematical voodoo magic in mathematics that you don't know. You know you have to calculate it. You calculate it through a formula, but you don't really know what it means. Okay? So by its most basic essence, gradient just measures how steep the slope is. Alright? Gradient is a measure of how steep the slope is. Okay? What does it mean by steep? If you have a slope is basically a straight line. If you have a slope that is very steep, it's basically harder for you to climb up it. Right? Okay, so you must imagine if you have a gradient, if I tell you a value of a gradient itself is meaningless. But it is meaningful when we compare two things. For example, if I have a gradient, don't need to write this down, I'll just give you an example. I have a gradient that is 2, and I have another line that has gradient that is 100. Okay? When I look at these two numbers, immediately I know that the gradient on the right is steeper. So in your head, you should have a mental idea of how it should look like. So if I were to draw this line, and let's say if I were to draw it to scale, if this line is something like this, it is a very gentle slope of the gradient of 2, then I would expect this line of gradient of 100 to be much steeper. Okay, can you get it? Okay, so you must understand what is gradient, because a lot of you will graduate from here and you will not know what the idea of a gradient is. Okay, so it's very important to understand what is gradient. Now, secondly, other than talking about the magnitude, which is the number, the value of the gradient, it is important to know that gradient can be positive, a gradient can be negative. But what does it mean to have positive gradient and what does it mean to have negative gradient? Now in mathematics, positive or negative just tells us direction of things. Okay? So when we have a positive gradient, it is because by default, okay, by convention in mathematics, we always go from the left to the right. Okay, so means we always start from the left, we go to the right. If we go upwards, if we head upwards, that means if you look from the left to the right, you go in the upwards direction, the gradient is positive. But if you go from the left to the right and it's downward sloping, means for example, I just write something here. Let's say I have a gradient of negative 2. It is downward sloping. From the left to the right, it goes downwards. That means the gradient is negative. Okay? Then for negative gradient, what does the magnitude mean? What does the number tell us? If I have a number that is very negative, let's say it's negative 100, I just need to know it is very steep. But you go from left to the right, it goes downwards. Is that clear? Okay, so these are the basics of gradient that you should have already known when you are in set 1. Okay, you should already know this when you are in set 1. But I know a lot of you have either forgotten or you never ever bothered to find out a little bit about it. Okay, so it is important for you to know this before we actually move on to this chapter. Because I can tell you, if you know all these basic things, right, this chapter is relatively easy. I can tell you one thing in eMath. Most of the workings are not very tedious, that's number 1. Number 2, they only test you on basic concepts. If you understand your concept, you realize that your working is very fast, very smooth, and you can get the answer relatively quickly. Okay, it is no wonder that actually E-Math has the highest number of distinctions, has the highest number of pass rates. Alright, in the whole of Singapore, in all exams. You can go and you can find any exam, you will not find any paper easier to score than an E-Math paper. Okay? I don't think there's any. Okay, it's even higher than English pass rate. Okay? So when you look at this thing, there is now one formula that I need you to change your mind. Gradient is no longer the rise over the run. It is actually y2 minus y1 over x2 minus x1. What is this? Okay, so maybe we look at this graphically so that we can actually understand. Now, if you recall, earlier in Set 1, we learned that the gradient is the rise over the run. What is the rise? Rise is basically, remember we always look from the left to the right. We look from the left to the right. We ask ourselves how much do we have to rise vertically from this point to get to this point, how much do we have to rise vertically? Now, isn't the rise the same as y2 minus y1? Okay, which we are finding the length of this portion. We are finding the rise. You need to be able to see it. Okay, you need to be able to see it. So stare at this carefully. Can you see that y2 is this coordinate over here? If you minus the y1 over here, you get this length over here, which coincides. This is the rise. Likewise, if you want to find the run, what is the run? The run means when you go from the left to the right, what is this length over here? You can find it by taking the x2 minus x1. I give you a concrete examples. Okay, sometimes with examples it's a little bit easier to see, right? So let's say this is 2. Right, this is unit of 2, 3, 4, 5, 6, 7. This is 7. Okay? Now instead of you manually counting and say, hey, what's the length of this one? This 2, each block is 1. Oh, 1, 2, 3, 4, 5. This is 5. No, you can just take 7 minus 2. Right? So it's much faster. Likewise over here, if you want, let's say, let's count, this is 1. Okay, so I say this y1 is at 1. Okay, and this is 2, 3, 4, 5, 6, 7. Oh, this is 7 as well. Now, instead of me counting, how many, what's the length of here? Each block is 1. 1, 2, 3, 4, 5, 6. I can just take 7 minus 1. Okay, so this is where the graph, the formula comes in handy. Okay, if you understand the formula, you don't need to memorize it anymore. Okay, so I'm a really huge fan of understanding. Because when you understand, you don't have to memorize anymore. Alright? Okay, so let us look at the first example. Find the gradient of the line joining the point A and B. Okay? So first thing, when you start out baby steps, always write down the formula until you can memorize it. So I know the formula is M is y2 minus y1 over x2 minus x1. Okay? Remember, it is always the y divided by the x. It is the y divided by the x. The common mistake is people put the x divided by the y. So remember, it's the y over the x. Okay? And then, when you look at here, it doesn't matter which one you say is your point 1 and which one is the point 2. Okay? It really doesn't matter. If you do both ways, it will also work. That's the beauty about this formula. Okay? But you may want to label this as x1. This is your y1. This is your x2, this is your y2. Okay, so what you can do, baby steps. But of course, when you get proficient enough, a lot of you won't do this anymore. Okay, but it's just for you to be able to see. Okay? So I hope you guys still remember, these are coordinates. Okay, these are coordinates. This is the x, this is the y. Okay, this is the x, this is the y. This subscript over here, the 1 just tells us that this is point 1, this is point 2. Okay, so we can easily substitute it. y2 minus y1 is 8 minus 2 divided by 5 minus 1. That is the gradient. So what's the answer? It's equals to 6 over 4, which simplifies to 3 over 2 or just 1.5. Okay, whatever floats the boat. Okay, so it's relatively simple. This chapter is really not too difficult. Really, it's not too difficult. In fact, I love this kind of questions when I was a student when it comes out for O-level because it's really very direct. Okay, and most people people do score well in this. Okay? Now let's move on to example number 2. Find the gradient of a line joining the points C and D. I teach you guys a faster way to do it. Okay? So you know that the gradient is y2 minus y1 over x2 minus x1. I just need to take the back one minus the front one. 2 minus 3 divided by 4 minus 0. Okay, so I'm going to get negative 1 over 4. Answer is negative 1/4. Okay? Now I want you guys to try something. Okay? Because sometimes when you do something, then you learn from it. Now, I took, in this example, right? In this example, I actually took this as my y2. I took this 2 minus 3 divided by 4 minus 0. What if we took this 3 minus 2 divided by 0 divided by 4? Would you get the same answer? Try. Right, try. Okay, so if I use it as a different y2, so I take 3 minus 2 divided by 0 minus 4. What am I going to get? I'm going to get 1 over negative 4. I get negative 1/4. Okay? What am I trying to say here? Sometimes a lot of you get stressed out in the exam. You say, oh, I know the formula is y2 minus y1 divided by x2 minus x1, but I do not know which one is my x1, which one is my y1. Does it matter? Absolutely not. Okay, it doesn't matter. Just be consistent. If you say this is your point 1, then this is your point 1. If this is your point 2, then this is your point 2. Okay? Just take one minus the other divided by this over the other. Okay? It takes a little bit of practice. Let's look at example number 3. I'm very sorry, but example number 1, example number 2 will never be tested in exam because it's too simple already. More often than not, you will see example number 3. Okay? Let's look at this question together. Given that the gradient of a line passing through negative 2 and 6 and 5k is negative 4 over 5, find the values of k. So how do you do that? Okay? They already give you the gradient. The gradient is negative 4 over 5. So you know the gradient, right? For those of you who still don't know, a bit blur, right? The gradient is y2 minus y1 over x2 minus x1. And I do know that the gradient is negative 4 over 5. Which is my y2, which is my y1, doesn't matter. Okay, but I take this one as 0.2. So I take k minus 6 over 5 minus negative 2. Okay? You have an equation, you only have one unknown. Is it that difficult to solve? Not really, right? Okay, so what you're going to do is you're going to simplify this thing over here. So I'm going to get negative 4 over 5 is k minus 6. My denominator here is 7. I can cross multiply. Negative 4 times 7 gives me negative 28. 5 times k minus 6, negative 28 is equals to 5k minus 30. I bring the 30 over, so negative 28 plus 30 equals to 5k. So 2 is equals to 5k, so therefore my k is equals to 2 over 5. Okay, this is a typical question, 3 marks. Okay, this is a typical question in your E-math that you can expect to see for your WA. Okay, this kind of question you can expect to see in your WA. Okay, is it doable? Yes, as long as you remember your concepts. As long as you remember your concepts. Can you try by yourself example number 4? It is the exact same thing. I'm going to leave this example up over here, so if you are lost, you can refer to it. Okay, try it. I will also write down my answers at the bottom. If you are done, you look up, you check your answer with mine. Okay? Okay, when you're done, you just look up and just check your answer with mine very quickly. Yes. Okay, any questions regarding this one? Anyone that is a little bit unsure, or maybe I went a little bit too fast? Okay, so you can see E-math is a lot simpler, right, than E-math. Don't have very long tedious workings. Okay, so I hope you guys, whenever you see E-math, I hope you guys can know that, okay, this is a subject I can score it. Okay, I don't want you to be too scarred by E-math. You must know one thing, I'm repeating many times already. Okay, E-math, you cannot fail. Because if you fail, you cannot go poly. Okay, and every year the C4 class, the triple science class, always got one person fail one. For the last 5 years, I checked. I don't know why I always got one person fail one. E-math. Okay? Hey, you guys are not supposed to have any failures. Okay? So I remind you guys again, A-math, you probably can afford to fail. I do not want you to fail, but you can afford to fail, you still can go poly. But E-math, if you fail, it's either you take one more year again as a private candidate, or you go ITE and spend 3 years there. Okay, before you go poly. Okay, so please don't fail E-math. Okay? Okay, let's move on to the last one from this subchapter. Find the gradient of the line y equals to 3 over 2 and x equals to 2. Now, this one is a concept question. If you are the kind that applies formula, you will not be able to do this question. Okay? So how are we going to do this question? You must first understand what does it mean for it to have a line y equals to 3 over 2. Can you first just draw a Cartesian coordinate out? Cartesian coordinate means you just draw a x and y axis. Okay, so this is a y and this is a x. Can you please just draw it out? Okay, for those of you who already got the answer, good. That means the concepts are relatively strong. Okay, for those of you who do not know the answer, don't even know how to start, you try to say, hey, I'm trying to apply the formula, but I cannot apply anything, I'm not given anything. Okay, that means your concept is still rather weak. Okay, let's focus on A first. What does it mean when the line is y equals to 3 over 2? 3 over 2 is just 1.5. It is a straight line. Y equals to 3 over 2. That means at every single point in the line, the value of y maintains at 3 over 2. Where is y is 3 over 2? Somewhere here lah. I also don't know. Right? So I can say that this is maybe 1.5, which is 3 over 2. If there is a line that everywhere is 3 over 2 or 1.5, do you not agree with me it will have to be this straight line? Because any point on this line, the value of y is 3 over 2. Okay? So hopefully you guys understand. Okay, why a horizontal line is y equals to 3 over 2. Okay? Now, once I draw this out for you, you should be able to tell me what is the gradient of this line. Don't even need to do any calculation. Remember, I want you to recall, what is the definition? What is the definition of a straight line, or what is the definition of a gradient of a straight line? Maureen, what is the definition of a gradient? How steep? So how steep is this? Huh? How steep? Huh? How steep? Is it steep? Not steep. Not steep in mathematics is 0. The gradient is 0. Okay? Because it's not steep. There is no steepness at all. Okay? It's completely flat. Okay? So there is no steepness at all. So we say the gradient is 0. Can you understand this? So for A, okay, for part A, M is 0. Can you understand? Okay. Now let's move on to the second one. Okay, x is equals to 2. X is equals to 2. Again, let's say 2 is over here. I just draw a straight line. Okay, I'm going to draw a straight line. Down here, let me change color a little bit. I am going to change to purple. Okay, I'm going to draw a straight line down. Oops, didn't really cut it too. Okay, so this is x is equals to 2. Why is this x equals to 2? Because at every single point in this graph, on this line, the value of x is always 2. Okay? Now I have a question. Then what is the steepness of this line? What is the steepness of this line? Now you're mounting something. What is it? What do you think it is? What is the steepness? No calculations needed. Huh? 0? If you are saying it's 0, is this line steep or not? Very steep, right? But you're not able to put a number to it. Why? Because it's infinitely, maybe it's infinitely steep. The answer is undefined. Undefined. Okay? So for part B, it is undefined. Okay, we don't know the exact value. We don't know the exact value of this steepness because it's a vertical straight line. Now, mathematically, why is it undefined? Okay? Mathematically, why is it undefined? Let's go back to the formula because some of you are unconvinced. What do you mean undefined? Okay, what does it mean to be undefined? If you use the formula, right? If you want to find the formula for this gradient, it is the y2 minus y1, right? So let's say, if you want to find y2 minus y1, I need to choose 2 points on this line. Right? I choose 2 points on this line. What is the rise? Doesn't matter what's the rise. Let's say the distance between here and here is 10. Okay, I don't know. It doesn't really matter, right? I just anyhow choose any 2 points. Okay, so I'm going to say it's 10. Okay, but what is the run? It is a vertically straight line, so the run is actually 0. Can you divide anything by 0? You can't. That is the reason why it is undefined. Okay? Because when you try to divide by 0, hey, it's undefined. Okay? But this question, you can do 2 methods. You can either understand it from the graph, it's because it is a completely straight line, there is no way for you to put a value to it. Okay? Or you can do it mathematically. Okay, you can do it mathematically. Okay, even for the top also you can do it mathematically, yeah? Okay, if you want to find the change in y, you realize that, hey, there's no change in y because it's on the straight line. 0 divided by anything gives you 0. That's why the gradient is 0. Okay? So I hope you guys understand a little bit better. Okay?